Hey everyone, and welcome. So here's a fascinating puzzle for you. How do you get a mathematical model, something that only really understands numbers, to understand a concept like gender or someone's college major? Well, today we're going to break down exactly how to translate those words into numbers. It's a technique that unlocks some seriously powerful insights into your data. Okay, let's just dive right in. Statistical tools, especially something like regression analysis, are amazing. But they have one big requirement. They thrive on numbers, things they can add, subtract, multiply, do math with. But so much of our data, so much of the world, is described in words. So what happens when your dataset speaks a language your model just doesn't get? And here it is, right here, the conflict in a nutshell. On one side, you've got your beautiful numerical data, SAT scores, GPA, stuff that regression just loves. But on the other side, you've got what we call categorical data, words, like gender or major. How in the world do we bridge that gap?
Yeah, it's not as simple as just typing these words into our analysis. I mean, think about it. A math equation has no idea what to do with the word male. It needs a number. So what we really need is a translation guide.
And that brings us to a surprisingly elegant answer. Let's talk about what I like to call the 0 and 1 solution. So the hero of our story today is something called a dummy variable. You might also hear it called an indicator variable. Honestly, the best way to think about it is just as a simple on-off switch. It gets a value of 1 if a category is there, the switch is on, and a value of 0 if it's not, the switch is off. It's really that simple.
All right, theory is great, but let's make this real. Let's see this thing in action. We'll start with the most straightforward example there is, a binary category like gender.
Okay, so here's our data in its original form. This is the before picture. We've got our salary column, which is a number, so that's fine. But then we have the gender column, which is full of words, male and female. Right now, this table is a no-go for our regression model. And check this out. Here is the after. We've totally transformed it. The old gender column is gone. In its place, we have a new column called male. Now, if the person is male, this switch is on, so the value is 1. If the person is female, this switch is off, so the value is 0. Just like that, we've successfully translated the concept into numbers our model can understand. Now here's a really important concept to grasp. The category that gets the 0, in our case, female, it isn't just forgotten. It becomes what we call the reference group. It's the baseline. So from now on, our model is going to ask questions like, compared to a female, what is the effect of being male on salary? Everything is measured against that baseline. Right, that makes total sense for a simple on-off choice. But I know what you're probably thinking right now. What happens when you have more than 2 options? What if you're looking at something like education level, which might have 4 or 5 different categories? And that is the perfect question. Because to handle that, we need to fully understand how to use this idea of a reference group. The solution has a name, and it's a fundamental rule you've just got to know for this kind of analysis. It's called the K1 rule. Now, I know it sounds a little technical, but the logic is actually crystal clear. It just means that if your variable has K categories, you only create K-1 dummy variables. And this is the most important part. You always intentionally leave one category out. That one becomes the baseline for comparison. Let's just walk through this with our education level example. We've got 4 categories here. So K is 4. The rule says K-1, so 4 minus 1 gives us 3. That means we need to create 3 new dummy variables. Then we just pick one category to be our reference group. Let's go with high school. And this table just brilliantly shows how it all comes together. Look, for someone with a PhD, the PhD dummy variable gets a 1, and the others are 0. Simple enough. But now look at the row for high school. All 3 of our new dummy variables are set to 0. That's the signal. When all the switches are off, the model knows it's looking at our baseline, our reference group. So why do we have to do this? Why leave one out? Well, it's to avoid this nasty statistical trap called perfect multicollinearity. Put simply, if you made a dummy variable for every single category, the information would be redundant. The model would know that if the bachelor's, master's, and PhD switches are all off, the person must be high school. That redundancy basically confuses the math and causes the entire analysis to just break. And here's the payoff. This is why we do all this work.
The results from your analysis, your coefficients, will now tell you exactly how much more or less someone with a bachelor's, a master's, or a PhD earns compared to someone with a high school diploma. You can finally measure the precise impact of each category against your baseline. It's incredibly powerful.
Okay, so that's how it works in a perfect, clean, textbook world. But as anyone who's ever worked with data knows, the real world is, well, it's messy. So let's talk about cleaning up real data. When you're out there in the wild, you're going to run into two major issues all the time. First, you'll have missing values, blanks or nulls, and you'll have to decide what to do with them. And second, and this one is a classic tripwire, you'll have inconsistent text.
I mean, look at this. This happens all the time. To you and me, bachelor's and bachelor's degree are obviously the same thing. But to a computer, they're two completely different categories. So before you even think about making dummy variables, your first job is to go through and standardize all these entries into one consistent format.
And hey, here's a very practical pro tip, especially for those of you using a tool like Excel. For its regression tool to actually work, all of your input variables, all your independent variables, have to be sitting right next to each other in adjacent columns. It is a tiny formatting detail that will save you a massive headache, trust me. So after all that cleaning, all that standardizing, and creating all our clever on-off switches, we are finally ready for regression.
So here's the big takeaway. By thoughtfully turning words into a simple language of zeros and ones, you haven't just changed your data. You've unlocked the ability to ask much deeper, more interesting questions. You can now include all of this rich, descriptive information in your most powerful statistical models.
So you now have this fundamental technique for translating the world of words into the world of numbers. The real question is no longer how you can do it. The real question is, what hidden stories, what unseen connections are you going to uncover in your own data?